So here we are talking about a finite geometric sequence, or finite as some people like to call it. And so what that simply means is that it goes to a definite term or a definite number. So for this, it's going to tell you that it wants the sum of either 1, 2, 3, 4. It's going to tell you exactly how many terms it wants you for, and it gives you a formula to follow that. So it wants the sum of a certain amount of terms. So find the sum of the first 7 terms of the geometric sequence whose nth term is decided by this formula right here. And it specifically says to use the formula, so I'm going to show you how to do that in this one. Okay, 7 is what's going to be our n in this, and we're going to use the formula to find the first term, which is 16, and our rate, which is 1/2. Okay, again, we're going to make sure we know that n is represented by 7 because it wants the first 7 terms. Okay, we have a sub 1, we have our first term, and we have r. So now we have a formula that we are going to use for this. Okay, so here's the formula. I'm writing it down for you. So it ends up being 16 times 1 minus 1/2 to the 7th power, all of that divided by 1 minus 1/2. Okay, so what we're going to do first is we're going to make sure that we take 1/2 and take it to the 7th power. So we've got 16 times 1 minus 1 over 128. 128 is just simply like saying 2 times 2 times 2 times 2 all the way up to the 7th power. And then we're still dividing all of that time by 1 minus 1/2. Okay, we have to take this 1 and we have to make sure that we change them to where they are least common denominators with the things they are subtracting. So the first one is going to change into 128 over 128, and we're still subtracting 1 over 128 by that. And then the bottom one is going to be 2 over 2 minus 1/2. I forgot to put that at first. Okay, so we are going to end up with 16 times 128 minus 1, which is 127 over 128. And then on the bottom, we're going to be left with 1/2, because 2 over 2 minus 1/2 is just 1/2. Now, what we can set up here is we can simply flip the bottom fraction to make it to where we do 16 times 2, and then we'll be left over with the multiplying. So 16 times 2 is 32, and we're going to multiply that by the 127 over 128. Now, 32 and 128 are both divisible by 32, so we're going to cancel out 32 and make it a 1, cancel out the 128 and make it a 4, and we are going to have our final answer, which is 127 divided by 4. Now, in your book, you may put this as a decimal. I can figure that out if I need to. It's not that big of a deal, so don't worry about it if you put this into the calculator and you get a decimal for it. Don't try to put it back into fraction form. Okay, example B says, find the sum of the first 6 terms of the sequence. So I'm going to circle the 6, 3, 6, 12, 24, without finding the remaining terms. So we know that 3 to 6, 6 to 12, 12 to 24, our rate is 6 divided by 3, which is 2. So I'm going to write down what I know for this. So I know our first term and our rate. Our first term is, and I know n as well. So our first term is simply 3. Our rate is 6 divided by 3, which is 2, which I already told you. And n is 6 because it is the 6 terms, the sum of the first 6 terms. Okay, we are going to use that same formula we used in the previous one. So we're going to set this up as our first term. I got ahead of myself there. So 3 times 1 minus 2 to the 6th divided by 1 minus 2. So this is 3 times 1 minus 64 is what 2 to the 6th is. All of that divided by 2. Oh, negative 1, sorry. 1 minus 2 is negative 1. So I've got 3 times negative 63 because 1 minus 64 is negative 63, and all of that's going to be divided by negative 1, and my fan is blowing my paper all over the place. So 3 times negative 63 is negative 189, and we're dividing that by negative 1, which is going to give us a positive 189. Okay? And that is how you find both of the two different types of equations. So when the rate is a whole number, it makes the whole equation seem a lot less complicated. I personally prefer these. I don't like fractions, neither do you guys. It's okay. And we're going to stop there.